Today, we're looking at a wild theory, one that says modern physics is built on a huge mistake. See, physics has a massive problem. Its two main theories, they're completely incompatible.
General relativity and quantum mechanics just can't both be right, and that's the biggest crisis in physics today.
So, let's take a look. We'll explore this new idea, motion-first physics, and its huge claims. It's called motion-first physics, or MFP, and it flips everything on its head. It says motion is fundamental. Okay, so the theory starts with two wild ideas. First, a perfect, true infinity is the same as absolute nothing. And the second idea? Our universe is just a single permanent flaw that breaks that perfect balance.
From just those two axioms, Whitlock gets one single master equation to describe, well, everything. It's called the WFE.
And what's really cool is each part of this equation describes something real, a physical action, like pressure or spinning. So what kind of universe does this math actually describe? Well, in this model, everything is a whirlpool. MFP claims there's one single pattern that just repeats everywhere, from tiny electrons all the way up to galaxies. Yeah, it's a huge claim. The theory says this new model solves literally every single paradox in physics. Take dark matter, for instance. MFP says it's not missing matter at all. It's just motion we haven't accounted for. What about Einstein's time dilation? It's not about warped spacetime, it's about objects physically getting squished as they move. And that spooky action at a distance is just two particles vibrating together in the same motion field. Okay, so here's the big question. Is any of this for real? Should we take it seriously? Well, on the one hand, it's super elegant. You get one equation for everything and no more singularities. But on the other hand, it was developed totally in isolation. It hasn't gone through any real peer review. And this is where it gets interesting. It's that classic battle, the establishment versus the outsider. What's your take?